Hi, everyone, and welcome to the next installment of the CoreAVI podcast series. My name's Neil Stroud, and I'm the VP of Business Development and Marketing. And today we're going to talk about an interesting topic related to the automotive market. So we're seeing increasing technology and in-car sophistication happening, and we wanted to discuss and debate a little bit how that's impacting the automotive supply chain. I'm joined by two industry luminaries today who are going to help us navigate this conversation. So first of all, I'd like to welcome Tero Sarkkinen, the CEO of Basemark. Hi, Tero.
Hey Neil, and hey everyone, nice to be here. Thank you for the opportunity.
Thanks for joining us. And secondly, Damian Fozard, the CEO of CoreAVI. Hi, Damian.
Hi Neil, how are you doing? Hope everybody's well, and thank you for joining us.
Okay, let's jump into the first question. So I wanted to start by just setting the scene of some of the trends that are happening in automotive, right? So we know, ADAS is progressing at a great rate of knots. We're seeing increasing numbers of ADAS capabilities going into the everyday vehicles that we drive, and of course we continue the march towards fully autonomous operation. Um, but we're starting to hear new terms in the industry, things like software-defined vehicles. So I wanted to just kind of dig into that one a little bit because I think we've talked about autonomy and ADAS quite a lot as an industry and certainly between ourselves as well. So what is this software-defined vehicle that we keep hearing about, and why is it important? Why has it emerged as a thing? Tara, what do you think?
Yeah, I think we are on the way towards software-defined vehicles, and this trajectory started for many OEMs already, maybe over 10 years ago, where they started to hire first the first software engineer, and then the next, and then a few more. And now we are on the cusp of OEMs finally making architectures that enable dynamic over-the-air updates of even core functionality for the car, and this is what's basically driving this trend.
Damien?
I think the interesting part of both the driver and the outcome of software-defined vehicles is the concept of actually what makes a car function, and the idea that software increasingly determines the capability of the vehicle is something that's relatively new. We've seen, for example, Tesla go as far as to make features available or not available in a car based on a software parameter change. So every seat in the car may be technically capable of being heated, but unless the software is enabled, that functionality doesn't exist for the end user. That's a fairly trivial example. And as we move towards more ADAS and autonomous features, the ability to increase and update the capability of the car is an essential feature for viability. And I think, if you go back 10 years, we'll have all experienced the I guess almost buyer's remorse with things like in-car entertainment systems, where, the system is kind of up to date and looks good for about 3 months after you've bought the car and drive it. And then the next evolution of technology and interface moves on, and all of a sudden you're looking at something that looks like the Star Wars game from the 1980s, which is completely different from the rich technology that is around you. So that kind of application-led perspective on the vehicle has fundamentally changed what the vehicle has to be, how the vehicle has to be built to support it. And I think that's the interesting kind of almost unknown aspect of software-defined vehicles. As they change the infrastructure, the application can change. As the application can change, it puts pressure on the infrastructure. So there's this kind of, depending on where you sit, vicious or virtuous cycle of technology capability interchange.
So is the software-defined vehicle something that you think is consumer-driven, or is it the OEMs having to make that step to make things more scalable and reduce the cost of development and get better ROI? Tero.
Yeah, I think the consumers certainly influence this, but it's the OEMs who face the difficult task of basically fulfilling those, and actually they should even like exceed the today's expectations. For the design cycles are so long, so you might have a car that starts new generation shipping from the factory today, that architecture and hardware was fixed maybe 4 years ago, and at that time that chip was maybe top of the line, but or it could be already that the chip itself was 4 years old at that time because it was proven and it's available. So this means that the brand new car you get from your dealer today might have like 8 years old hardware running behind the scenes, and then obviously during 8 years all these digital experiences and services and apps have developed quite a bit, and the OEMs have a difficult task of then basically offering to the consumer something that looks at least a little bit fancy and sexy in today's world. And as Damian said, too often still it can feel like that Star Wars from the 80s. So OEMs certainly know this, and little by little I think they are more capable of answering to this need. But there's still a long way to go, and these development cycles, as I mentioned, and having to run modern looking fancy stuff on ancient hardware, that's a difficult equation.
I actually think it's the disruptors or potential disruptors in the marketplace. People who um, come to the table with a completely different outlook from the OEMs and who have traditionally held the mass part of the market. Tesla is an obvious example, but even if you look at Fisker, the whole concept behind their car, design-led automotive product, as opposed to engineer-led product. They just have a completely different concept on the user experience of the car and the vehicle. Um, and I think what that does is, the disruptors in any market create pace of change. And if you're the incumbent, you have to match that pace of change. And really, what's interesting for to observe now is the pressure that puts on the supply chain, and the pressure that it puts on how the more traditional manufacturers go about um, designing, updating, implementing cars in a market with disruptors. The they haven't really had to face that through probably about the first 100 years of their experience. It's all been engineer kind of um, lead based evolution. Um, maybe things like gas prices being the major disruptor in terms of design and feature set. Now it's a bunch of crazy ideas generated by engineers um, to really just completely think of the car in a different way, and to prioritize things that I don't think the manufacturers would have chosen to do themselves if the disruptions hadn't hit the marketplace. Yeah, would we see so many electric vehicles out without, again from the established brands, had there not been, a Tesla? I would doubt it.
So, and you bring up a good point, Damien, between the kind of the incumbents and the disruptors, and certainly we're seeing more and more disruptors beginning to play in the automotive market. Just thinking about the incumbents for a moment, though, historically these OEMs have kind of owned everything top to bottom and been fully in charge of their own destiny. And I think it almost feels to me like, they can't support that anymore, but just because the level of technology is so complex and moving so fast. So are they having a realization now that they can't own everything top to bottom, and they've got to give up some of that control to the supply chain? Is that the reality we're living in now?
Yeah, or at least it doesn't make sense that each and every one of them develops separately everything from top to bottom, because only the parts that differentiate the user experience, those are relevant for the OEM and their brand. And then there's a lot of layers and functionality that just has to be there for every car, but doesn't differentiate a car. So those pieces should be standard and licensed from a third party.
I agree. Every kind of incumbent car manufacturer should be buying everything from Basemark to make life easier for them.
Thank you. and wait, there's more. If you buy today, we give a 5% discount.
It is interesting. I think we've seen this in other markets where there's a realization that it is your differentiators that are important if you're the end product manufacturer. It's the thing that the consumer can look at and say, that's different on this brand versus on that brand. And if it doesn't make a consumer impact, then your mindset about it shouldn't be about control. It should be about how effectively and efficiently you can deliver that capability in your vehicle, because the better that you can do those things, the more energy and research and focus you can put on the differentiators. And in a supply chain which has typically been about cost management, and it's been about the kind of the control and not and getting things done in a way where if I can buy this light 3 cents cheaper than the competitive because I own something about that supply chain that allows me to do that, that's an end point differentiator for the manufacturer. I think that the disruptors, the emphasis on end user experience is starting to change that dynamic, and it's about, can I get the capability with time to market, solving some of the problems that Tero mentioned earlier on. I don't want to be trying to build my application on 8-year-old hardware and coming to the market with my new car, because I think that there was kind of implied in what we said earlier. As more and more of the car moves to being software defined, more and more of the capability and differentiation of the car moves to being software defined as well. And so if your supply chain cannot keep you at the forefront of technology, then your car capability, your brand, all of those things are going to suffer dramatically.
Yeah, and indeed, and there's even this, that when you now design a car and you design then all the, let's say, digital services, digital luxury and apps into that, you don't know what you will figure out year, 2, 4, 5 years from now. So it's analogous to basically developing and running an online multiplayer game, where you start with a certain scene, but then you need to add the content over the lifetime to keep basically the users, let's say, hooked. And I think this software-defined vehicle enables and basically changes the car industry in such a way that cars will have developing set of features and functions over the lifetime, and some of those even the design team didn't think of when the car was first sold. And for this reason, choosing the hardware that has ample enough headroom, ample enough capacity for all those future things. So that's needed. And what I've seen too many times in the industry, indeed, like Damian said, it's this cost optimization where basically, if I can knock off $5 off of a price of a chip, then it's a good thing. But then it might mean that the performance of this chip is half of that better chip or something silly like this. So this chip selection is done by one team much early in time, and then that's a fixed and that's a given, and then come basically the application team and people and executives who say that, we need this and that and that and that. But then if your hardware is fixed, that it's ancient and it's low powered, then it's really big dilemma. So this has to change.
So that's a great point, Tero. I'm going to come back to the silicon part of the discussion a little bit later on, but it sounds from the discussion so far that the supply chain has an even more critical role to play in this new world that we're driving towards, no pun intended. So how are we seeing the supply chain change and adapt as a result? Like, have you got some examples of that?
Yeah, I can at least give how it looks from a software company point of view, like from Basemark's point of view. We are becoming like a mini tier one, like that only provides software, but we work directly with OEMs. And previously there was like no way, everybody had to go through a traditional tier one who would basically then bundle together maybe 50 different other suppliers. But now the OEMs have realized that particularly for software and digital things, such a thing is not needed, and they can sort of bypass that middleman in the value chain on some cases. And that is certainly a new disruption in the value chain in the industry and opens up a lot of new interesting opportunities for even startups and new companies.
I think it's interesting, this this concept of the digital tier one, and the kind of almost splitting the value chain of a vehicle into, you've got traditional physical kind of supply chain functionality, the wheels, the brakes, the kind of the traditional side. Even that is kind of under pressure with the electrification of vehicles. I know as a petrol head, Neil, you do not like us mentioning the idea of electric cars, but they are a reality, and a growing reality. And of course, again, they change that physical supply chain, because there's many of the existing manufacturers see opportunity for differentiation in how they go about electrification and capability. But that almost now is only half the vehicle. As Tero mentioned, you've got the digital aspect of the vehicle, which can be everything from drivability and capability in terms of how the vehicle moves, what functions it can achieve to support the driver, to support enhanced safety, to in fact even move towards, as we've talked about, automating for the driver. Then to the actual user experience of driving, um, the demands and of the end user. It's interesting to call. It's interesting to even think about calling drivers users, but that is the way the car is going. It's what the buttons can do. It's what your voice system can do. It's how you can navigate more easily. It's the experience that you go through inside the vehicle that is becoming more and more important. It used to be whether you had stitched leather seats, and now it's can I, you know, can I hold a conference call whilst driving down the motorway with crystal clear quality, with no background noise you know, in my audio, and all of those kinds of things that suddenly have moved to being buying decisions.
Yeah, it's when cars still needed to be driven by a human. the the biggest connection to the brand is basically when you hold the steering wheel, and what material is it? Is it leather or not? And how does it feel when you turn it, and or when you press the brake or the gas, and these kinds of very clear connections of the customer to the car. And now when we envision the future where there's no control, there's no steering wheel and pedals, and then it's like how otherwise can the OEM make, let's say, BMW feel like BMW, Mercedes like Mercedes. So there has to be quite a lot of other very concrete visual things, and maybe we call it digital luxury that surrounds you, and yeah, the crystal clear audio, and rear seat can have a widescreen THX certified movie experience, and things like that. But this is a big thing for the whole industry that I'm sure think tanks within the companies have been already thinking about hard for years.
I just relay an experience on that point that I had talking with some senior people in one of the major brands whose car I happen to drive, and I happen to drive one of their very latest models. Their first question about the car was, what did I think of the app, the mobile app that came with the car? Because they were really worried that their mobile app did not stack up to what the competition was doing. And they were right. Their mobile, the you know, you got a $200,000 car, and you again you pick an app up and it feels like something from the, I wouldn't quite go back to Star Wars game, but you know, it's clunky, and they seem to have missed the intuitive functionality that I want as a user from being able to remotely get my car to do something. Um, and so you say, you know, to Tero's point, this is a whole new set of things that they have to sort of start to imagine that were not on their agenda 5 years ago.
So I think what we're highlighting here as well, right? When we look at the supply chain as a whole, this evolution, perhaps even revolution, is driving a significant increase of suppliers and companies that want to play in the automotive supply chain. And if I put myself in the shoes of the OEM, that's going to give me a headache, right? Because I'm having to integrate, especially if we just think about the software piece, I've got to integrate all of this software from 100, 200, 300 different companies, and know that it all works together, and that issue gets compounded even further when you start thinking about the safety side of things. So how important is it that the ecosystem, the supply chain, works together to kind of do some of the pre-integration stuff? Is that a reality that has to happen? Is that beneficial to the OEM? And are we seeing that today?
Yes, it's a real challenge, that's for sure. And in in our status right now, or up until now, has been that the tier one does this complex work of integration, optimization, testing, and certification. And now that OEMs have realized that that's not cool, because all they got then essentially was a black box from the tier one, and if they needed to make any changes into that, let's say I want to have the font red instead of yellow, they needed to call back to the tier one even for a minor change, and this doesn't work obviously in this modern world. So it's a necessity that the OEM themselves are more able to control and manage and maintain or make modifications to the software stacks. And still it's just a reality that no OEM can or should alone do everything or write all the software by themselves. So there's a lot of building blocks and libraries and components that everybody uses, and they're all the same, so they will end up being like a licensable things. So it is, every OEM just needs to develop certain amount of this software integration and in-house integration and testing capabilities.
I think there's precedent for this in other markets, and it may be a more sophisticated and complex problem, but the idea of building an ecosystem and getting things to interoperate is essentially, the internet, and we seem to have pretty much solved that. You don't buy an email client anymore on the internet and not expect it to work with every internet provider that you, or every email address that you can possibly get hold of. But if we go back to the 1990s, if you had a Lotus email client, it worked with a Lotus email server, and that was it. That you could perhaps go and buy a piece of software which was the bridge from Lotus to something else. But we matured out of that. We built an ecosystem where everything was standards based, and I think that's the key here. It's we've all been to conferences in the last 2 years, and especially in the automotive industry, you hear the word collaboration. Everybody is searching for collaboration, but you don't hear quite so much how that actually looks in practice, and for some organization, collaboration means we dominate the world and it's our technology and everybody has a Lotus email server. That's the idea of collaboration in some minds. But the reality is we have a model. We know that it's about open standards, about strict adherence to that open standards, and then innovating on top of it. And if you look at something like the internet and you think cloud-based technology is just an evolution of some fairly basic standards to now create a rich environment where three guys in a garage can write an application and scale it to be a huge application to support millions of users without ever buying a piece of hardware, without ever having to solve any of the scaling kind of technologies. At some point, the technology inside the standard car is going to have those kinds of features. That's when we really have a software-defined vehicle. It's when you have the ability to do Docker applications, you have the ability to build a profile of this is a safe thing, car figure out how you execute it and keep it safe. We are evolutions away from that, but that is what the kind of the digital supply chain for vehicles is going to ultimately end up looking like, because it has to. Otherwise, we're going to be 10 years from now having exactly the same discussion.
Yep.
Because we'll have exactly the same problems.
Yeah, very, very much. It's a spot-on analysis. And now recently, I was very happy to see that these two big relevant standards bodies here, or standards, AUTOSAR and Kronos, they have announced that they are now starting to work together and bring better support of Kronos accelerated APIs onto the automotive software ecosystem. We are a member in both of these bodies, and that's really great. And particularly for me, who started a career like 25 years ago, on real-time 3D graphics or GPU programming, and I was even I think you can still find my name on OpenGL ES1 spec, and now seeing that all these things are merging and doing their own part in creating these standards to the industry that is basically needed for economies of scale and the whole scaling of the industry. So this is super important and super exciting.
So Tero, I wanted to go back to a point that you made earlier on. So as we get more into this software-defined vehicle world, what does that mean for the underlying silicon? Does it mean that it becomes more commoditized? What are the silicon vendors doing as a reaction to that? Because I guess this is changing their world as well.
Yeah. Well, looking from OEM's point of view, they always, in the automotive industry, they always need to have a plan B if something happens to plan A. And in today's world, let's say there's a chip shortage issue or even that there's a potential for new semiconductors to come into the market that are more powerful or cheaper or both. So the OEMs certainly want to have this separation between the application code and then the underlying hardware that executes it. And what's happening right now is that we've got CPU API standardized by programming language and GPU access standardized by graphics APIs such as Vulkan that enables also compute. But then there are now a lot of specialized accelerators. Each vendor has their own. It's a DSP or a DLA or whatever. And those are currently not yet standardized how the programming for these goes. And the industry has to solve this thing to make it a standardized API to access these and utilize these things. And OEMs certainly are proponents of this. But so we are, in terms of these specialized accelerators in silicon, I think we are right now where the graphics industry was before DirectX or OpenGL existed. And that will change, that's for sure.
I think it's actually it's an interesting situation that we're in, which is, the specialized silicon is increasingly showing less kind of performance and less capability over the continual rise of the generic. So you're now getting generic silicon that in some ways allows you to, in software, match what you would have had to have done in hardware in the past. And again, just going back to things like cloud technology, you actually do not care what manufacturer your cloud provider is using for the processors, whether they're GPU or CPU underneath, because actually what has happened there is you've got this concept of virtualization, which just hides everything beneath. It becomes a standard set of functionality. And I think that the march of APIs, of the creation of kind of collaborative standards and collaborative best practices, even rather than formal standards, eventually in the embedded world we'll end up with the concept of virtualized embedded. So the things that are typically embedded based problems to be solved, the swap issues, size, weight, power, heat, all of those other things, processor choices, etc., they all disappear from the application. They become non-application specific properties. We've been doing some of our kind of research in this area and thinking about the things that change. And One of our guys has come up with the idea of props. Which we're currently thinking about tops and flops and all of these kind of things for performance metrics, and if you, which is great, in a situation where you don't have kind of performance criteria you have to meet, you performance criteria you'd like to meet, but in a vehicle, it better be making, if it's driving itself, it better be running at a certain power performance kind of ratio and making decisions in a timely manner. So we've started looking at things like props, predictable operations per second, and genericizing the way that you think about the underlying hardware. And I think that's kind of is still very much at the early stages. But if I imagine the infrastructure of a software-defined vehicle 10 years from now, you actually do not care about which piece of silicon, how the silicon is constructed, whether it's 30 GPUs, 60 CPUs, and 4 DSP specialist processors, because that's all hidden and presented as a virtualized set of capabilities across these processors. And again, we have precedent for doing this in data centers. Yeah. I think there's a few things that are kind of are interestingly lagging behind. Backbones in vehicles. That's the backbone technology for intercommunication is one of those areas where the standard is, by modern day, it's more than 8 years old. The thing that they've agreed on in infrastructure. Um, those are the things that are kind of going to hold this virtualization back more than silicon and processors right now.
That is certainly how the future most likely will go. Though in the short term, there's still huge challenges in providing or getting enough oomph from the processors to do all the calculations needed for even ADAS functions, not to speak of autonomous driving. Because you take a look at the power consumption figures of some of the latest big boxes that NVIDIA or Qualcomm are coming up with, they still consume quite a lot of watts, and that translates directly in an inverse way to your EV's range. So I think the industry still has got a long way to go, many chip generations, to come up with energy efficient chips that can process enough. This I see is still a challenge for many years going forward.
Okay. Well, unfortunately, our time's drawing to a close. I feel like we could sit here easy for another couple of hours and talk about all of these big issues and work towards some solutions. It's clear from the discussion we've had that I think the automotive supply chain does have to adapt and is adapting, but there's still work to do there. Maybe if I just ask each of you just to kind of summarize where you think we are on that path, and are we heading in the right direction? Do we need to go faster? What do you think, Tero? Quick 30-second, 1-minute summary. How
Sure.
does life look?
Well, we are still far away from fully autonomous car that can drive itself in any condition, anywhere, in any time. And the moment that the industry solved this thing, we actually have then solved quite a lot of other problems as well. So when we really get into true AI, then a lot of things will unlock, and some of them are scary. But here we try to come up with the very useful and humanity beneficial use cases, and I look forward to that moment, and I know that there's years of work ahead, so I'm very happy about that for me and my company and shareholders.
Indeed. Damian, what do you think?
I echo Tero's enthusiasm for the complexity of what's in front of us. There are many problems to be solved. I think the exciting part of that is what that means is for people who are really specialized and know, how to do something really, really well, they're going to have a rich position in this ecosystem as it emerges. It's going to be an ecosystem of specialists rather than generalists for for the next 10, 20 years. It takes a while before you've done the innovation in an ecosystem to then the ecosystem become all about optimized supply. And while you're in that innovation phase, I just think it's a great time to be a technologist. I actually think, with not just with autonomous vehicles, but with autonomous everything coming, there's a lot of massive social drivers that are pushing this way. I think we're back to the kind of the age of the industrial revolution, where those people who are inventive and problem solvers have a rich vein of problems to solve, and that's where I sum up where we are right now.
Okay, thank you. So I think all that remains to say is thank you to our listeners for joining us today. Tero, kitos to you. Damian, thank you to you. And we'll see you next time for the next installment of the CoreAVI podcast series. Thank you.